Greetings, ladies and gentlemen. We're going to start this lesson about graphing exponentials by first reviewing a few things about what exponents are. Here's a few things you need to remember. If you have a number like 2 and it has a power up here, say 3, that means there are 3 2's being times together. And in this case, 2 times 2 would be 4, times 2 would give you 8. And you can put all sorts of powers up there. You can put 10, and that'd be 10 2's times together. Let's see, 4, 5, 6, 7, 8, 9, 10. And that's a fairly large number. All right, let's see, 16, 32, 64, 128, 256, 512, 1024, I believe is that one. That's my best guess. Sorry, kind of doing that in my head. But yeah, these things can get fairly big fairly quickly, right? If you just go to 10, you get a fairly large number. And just so you know, exponents can also be negative, and we'll kind of go with what that looks like in just a little bit. But the main idea of today's lesson is that you can graph an exponential, so be able to graph things like y equals 2 to the x power, or y equals, I guess they were using function notation. If you did f of x equals 3 times 1/5 to the x, we want you to be able to graph those kind of functions. So let's kind of go over what the steps are. Step 1, make a table of points. Step 2, plot those points. I know, it's crazy. And then step 3, you're going to connect it up in a curve. And this is going to make a curve, and you'll see why in a few moments. But yeah, so let's do some calculating with exponents again, just so you can kind of see what's going on. So in this first section, you got 4 problems or so, and 4 to 6, something like that. And you need to, it tells you an x value, and you need to put that in the equation here and compute. So this would be y equals 2 times 3 to the second power. If you were to do these by hand, you do have to remember that exponents happen before multiplying. So you're not going to do 2 times 3 and then square it. You're going to do 3 squared and then times by 2. 3 squared is 3 times 3, which is 9. So this is 2 times 9, which means it's going to be 18. And then we got something like this. Exponent being 0, you're going to put that up here. So you're looking at y is negative 5 times 1/3 to the 0th power. Anything to the 0 power is going to be 1. So you get y equals negative 5 times 1. And so that's just negative 5. But as you get more and more into these exponents here, you can use a calculator to help you out with those values. And if you're doing that, make sure it looks like this. If you're using the Desmos calculator, if you want an exponent there, there's a to the x button, or there's a x to the something button. I think it's a button. Anyway, it'll do that. If you're using a physical graphing calculator, there's a button that has an arrow that points up like this. It's right above divide. And this is the exponent button. So if I wanted to do 1/3 to the 0, I type in parentheses, 1 divided by 3, and then the exponent button, and it'll give me a 0 there. So make sure you know how to use a calculator to get these exponential values. But let's get to the graphing part. So step 1, make a table. So I can get some x's and y's. And I'm going to pick different x values here. You get to choose your x values. But I do recommend the ones that are close to 0 and the integer values. It makes it nice. And so now that I've picked some x's, I chose these. Again, you can choose your own, but these happen to be conveniently close and easy to calculate numbers. And I'm going to fill in this table. I'm actually going to start down at the bottom. These are easier numbers to put in. So if I put in 0, 2 times 0 is 1. 2 to the 0 power is 1. And you get 5 times 1. So this becomes 5. And you can then plug in 1 up here. 5 times 2 to the first power is going to be 5 times 2, because 2 to the first is 2. So I get 10. And then you can plug in 2. And you want to get 5 times 2 squared. 2 squared is 4. 5 times 4 is 20. Well, the reason I started with these ones is because I wanted to point out a pattern there is a pattern going down here. And you see we got 5 to 10, 10 to 20. That's the same pattern, and it is all times by 2. All right, 5 times 2 is 10, 10 times 2 is 20. And you could probably guess what the next one is going to be. You probably guessed 40. Yeah, it's just timesing by 2 as you go down. Which means if I'm going the other way, I'm actually dividing by 2. Because if you're going down is timesing by 2, going up is divide by 2. This one is going to be 5 halves, or 2.5. And the next one's going to be 5 fourths, which is 1.25. And as you get used to these exponentials, and by the way, you can plug these in to the exponent and you'll get these values here. You can use your calculator to do that for you. But I like using the pattern because if you just continue the pattern, if your x's are consistent, right, they just go up by 1 each, then your pattern is going to be consistent as you go through. So now we've filled in our table. Each row of our table makes a point. This is the point 0, 5. So I'm going to go 0, 5, put a dot. This is the point 1, 10. So I go 1, 10, put a dot. And then I got the point 2, 20, which is way up here. And if I go on the left side, I got negative 1, 2.5, which is here. If it's a decimal, you don't put it approximately where it belongs. And I got negative 2, 1.25, so it goes up 1 and a little bit here. So I'm looking like this. If I were to continue my table upwards here, I'm going to just make it go up more. I got negative 3. And if I cut this in half, I'm looking at 5 eighths, which is, what is that, 0.625, something like that. Anyway, it's something. It's 5 eighths, which is here-ish. Okay, so now I got a bunch of points here. You can connect it up, and it makes your curve. And an important thing you need to know about these exponentials is that they do continue left and right forever. And I want to talk about this part because a lot of people think it just, kind of curves and it kind of makes like this sideways V sort of shape or U shape. But over here on the left, it is actually never going to go below our x-axis. And the reason for that is because if you take a number and keep dividing by 2 and divide by 2 and divide by 2 and divide by 2, it's never going to switch signs. It's never going to start out positive and then become negative. It's all just going to be positive, but it's going to get increasingly closer and closer and closer to 0. And so on my graph here, and it's going down and getting closer and closer to 0. In fact, it gets so small it looks like 0. And so exponentials look like this. There's going to be a side that gets really, really, really close to our x-axis. It just gets increasingly closer and closer, but doesn't actually reach it. And then a side here that looks like it's almost going vertical. But again, it's not going exactly vertical because you can continue to go right. It's just going to get steeper and steeper and steeper. And that's how exponentials work. So that's how you graph an exponential. Let's try out another one so you can kind of see it. You may have noticed this one just has like the bottom of the graph, and that's because there's a negative here. It's going to go down, and it's going to be negative. Well, it's not going down. It's on the negative side of our x-axis. So let's go ahead and make a table here. Once again, you can pick your x's, but I'm going to just stick with my normal ones, negative 2, negative 1, 0, 1, 2. And if I find I want to go beyond that, I can. And I'm going to plug all of these in to my x value there. You plug in negative 2, plug in negative 1, plug in 0, and get things plugged in there. So pause the video and see if you can fill in the table, and we'll have you check in just a moment. Alright, let's get these things written in. Negative 3, negative 3 halves, which is negative 1.5. Negative 3 fours, which is negative 0.75. This is going to be negative 6 and negative 12. You may have wondered how I got all these. Well, this number in front is the y-intercept. So I just put that in for where x is 0, because that's the y-intercept. And I knew that this number, if you remember back when we were writing exponential equations, is what you're multiplying by. So as I go down my table, I am timesing by 1/2, which cuts things in half. So -3 becomes -3/2, which becomes -3/4. And if I go the other way, the opposite of timesing by 1/2 is timesing by 2, right? Because cutting in half and doubling are opposites. So I knew as I went up, I was going to times by 2. So I was able to fill this in pretty quickly just using what I know about my parameters of my function. This is your initial value, or y-intercept, and this is your growth factor. It's what's timesing by. So, anyway, I was able to fill in my table pretty quickly, and now I'm going to plot all those points. Let's see, got point here, this side, -6, and -12, and it's going to look something like this. And once again, on the right side, don't go up here, because it doesn't do that. It gets closer and closer to your axis, but doesn't actually cross, and over here, it's getting steeper and steeper. So there's another example of graphing exponentials. If you want to use a calculator to get your function values, go ahead and do that. But get this practice in of getting points and realizing what the graphs look like. Good luck.